Mitch, are you ready?
Yeah, Wayne, I'm ready. Do we want people to hold their questions for the end?
I think maybe if they if during the presentation they can just, if they have some questions, type it in, and then maybe I'll interrupt you as appropriate. But otherwise, okay. I think you're right. Just save the questions for the end.
Okay. Yeah, we'll have plenty of time at the end of the presentation for questions, everybody. All right. Well, with that, I guess we'll go ahead and get started. So yeah, as Wayne said, today I'm going to spend about the next 45 minutes or so doing an overview of the different AllJoyn service frameworks. So first thing here, I'm going to do a quick recap just on what AllJoyn is and a quick overview. If any of you haven't seen the previous two presentations in this series that Brian Spencer did, those go through the core of AllJoyn in a lot more detail. They talk through what bus attachments are, what interfaces are, how AllJoyn works under the hood. And so really, the focus of this presentation is going to be on the service frameworks that are built on top of AllJoyn. So as we've mentioned before, AllJoyn is really the glue for the Internet of Everything. And so it's composed of a series of APIs. And so APIs are good for developers because we use those every day. And so the idea is that we can use these APIs to have different things, different devices, different applications on a network talk to other applications. And so this is all done in a platform, chipset, and radio agnostic way. So really the way that happens is AllJoyn is a distributed bus. And so there's these different, all the different applications that can work either as a service, as a client, or as both. And that's what makes AllJoyn into this peer-to-peer system. And so all of the formation of this distributed bus is done in an ad hoc way, and that's accomplished by the advertising and discovery that happens as part of AllJoyn, which is also leveraged by the different service frameworks. And I'm going to go through some different examples of that in today's presentation. So without spending too much more time about overviewing AllJoyn, again, if any of the concepts that I go through in today's presentation are not familiar to you, be sure to go ahead and check out the previous presentations that go through the different fundamentals of AllJoyn, because that will definitely help with some of the terminology and concepts. But really what I want to focus on today are these core services. So these are really viewed as building blocks for a few different useful services that a lot of different devices and applications can take advantage of and leverage. So the 3 or 4 that we're going to go through today, there's notification, onboarding, control panel, and then we'll also touch on the config or configuration service. And so really these are services that are built on top of AllJoyn, and they're really designed so that developers can accelerate their application and device development. So instead of having to take AllJoyn and reinvent and code up these services on their own, they can go ahead and leverage what already exists. And so one important thing I want to point out before we really start diving into each of the different services, if any of you have worked with some of these before or looked at any of the source code or seen other presentations, all the different core service frameworks utilize the About feature for advertising and discovery. So in previous presentations, we've talked through how advertising and discovery work in AllJoyn. And so real quickly, I just want to go ahead and do an overview of About, just so that everyone's kind of caught up and familiar with that. Because as we look at some of the different pieces of source code today in the presentation, you're going to continuously see references to About and advertising and announcing. So I just want to make sure everybody's kind of up to speed on that. So depending on which part of the service you're using, you're either going to have an About client or an About server or service in your code. So either you're going to use About to let other applications and devices out there know what services you support and what kind of interactions you can allow, or you're going to use about to go ahead and see what else is out there. And so each service framework has several different code examples that come along with it. And so in those examples, you'll see how to set up the about code for your specific use case and how to initialize that. And so on each platform and each language binding, it can be slightly different. I mean, the underlying operation and functionality is the same, but depending on what language you're using and what platform you're on, it can be a little different. So for a good guide on just how to go through those different steps, there's an About Feature Usage Guide on the All Seen Aliance website, and there each of those guides talks through the different platforms and provides specific code and a specific example of how to set that up. So the next slide I want to go through here is just the generic AllJoyn and About setup. So all the different services that we're going to go through today that are built on top of AllJoyn and all the code examples that we're going to look at, there's about 5 or 6 different steps that are common to all those different examples. And so if you've ever worked with AllJoyn before, or if you've seen some of the other presentations that have been done, a lot of this will look really familiar. So every AllJoyn application is going to have a bus attachment. You're going to have a bus listener, and most likely a session listener or a session port listener, depending on if you're hosting or joining a session. And then again, your application may create a session, it may join a session, or it may do both. So that's just a lot of the common AllJoyn code that you'll see in the different examples that we're going to go through. And then moving on to About, as I mentioned before, you'll either create an About client or an About server. And so if your application is going to take a service framework and expose its functionality and ability to other applications, what you'll need to go ahead and do is use About and register your service framework with About. That way, when you use it to announce out to any other applications that are nearby, they'll be able to see, hey, this application supports notifications and control panel, or this device supports the onboarding service framework. And similarly, on the other side of the operation, if you have an application and you're trying to see what other apps, devices, and services are nearby, you can go ahead and set up an announcement handler in your application. And that way, every time an About announcement is emitted from another application, your handler will get called, and you'll get some of the metadata and context that you need to then go ahead and interact and connect up with those other services that are out there. Okay, so the first of the 3 service frameworks I'm going to go through today is notification. So first, I'm just going to go kind of do a quick recap of what the notification service framework is, and then I'll kind of dive deeper and go into what the interface looks like, and then we can go through some examples and some code. So the notification service framework, you can kind of think of it as like a text message for the Internet of Everything. The idea is to be able to send out a human-readable message, and then in addition to that, you can also include images, an audio reference, or other metadata. The notification interface itself is actually extendable, as we'll see in a minute. So you can put other data in there. And so with the notification service framework, there's really 2 sides. There's a producer or a sender, and then there's a consumer, or what we also call a receiver. And so depending on if you're producing or consuming notifications, you're obviously going to use the service differently. So just kind of a quick example of a real world use case of this. Imagine you have a refrigerator that has the notification service in it, and your freezer door is left open for maybe more than 5 minutes. So what could happen is the code running on that refrigerator could go ahead and send out a notification. And that notification could get picked up by a number of other devices that are in the home, like a mobile, a tablet, maybe your TV. And that way that notification can get displayed to the end user and alert them that, hey, you left your freezer open, you know, all your ice cream is melting. There's a lot of other different use cases too. If you take a look on the All Seen Aliance website under the interface specification document, that'll actually walk through a couple other examples that have been set up. So again, here's just kind of a quick diagram showing the freezer doors left open, the notification gets emitted. And then in this case, a TV might render it, but really the important thing here is to note that it doesn't have to just be the TV. It could be a mobile, or it could be some other device that hasn't even been invented yet that's going to come out in a few years. And so the neat part about the notification service is that the producer and the consumer don't really need to know about each other. So when the freezer sends out this notification, it doesn't necessarily need to know that there's also a TV nearby and 2 tablets and 3 mobile phones. It just sends that notification out. And then similarly, the notification consumer that's running on these other devices, they don't necessarily need to know what's nearby that's producing them. So this diagram here just does a quick overview of how the notification service framework fits in along with AllJoyn, how it fits in on the device, and then how the actual application that a developer would write ties in. So here we have, you obviously have the AllJoyn core framework itself. Then we have the notification service built on top of that. And then in both the producer app and the consumer app, you have a couple of calls that you'll make with the AllJoyn API, maybe to set up your bus attachment and advertise or discover with about. And then you'll also utilize the notification API. Now, whether that's to go ahead and create a notification and send it out, or whether it's to register to listen for different notifications. So this XML that we see here, this is the notification service interface. So as you can see, it's actually not that complicated. A notification is basically at its core an AllJoyn sessionless signal. So there's some different data in here about what version of the notification service is being used, an ID for the message, the type of the message. If you see this line here where we say, cover message type, so that can either be info, warning, or emergency. So obviously, as a developer, you'll want to use those in an intelligent way, and you know, only send out a notification with a type of emergency if there really is emergency, and if it really is an emergency. And we have some different examples listed on the website that kind of talk through and help with that. So additionally, there's a device ID, a device name, and an app ID and an app name. And this is really there so that when a consumer receives a notification, it can display to the end user, hey, here's where this notification came from, whether it came from your fridge, a washing machine, maybe another mobile device. So this next field here, the language text. So this is an array of a string and a string pair. And so what we'll see when we look at the code is that these 2 strings, one string actually represents the language identifier. So whether it's English, Spanish, German, French, you know, any number of different languages. And then the second string is actually the notification text itself. So whether it's something as simple as hello, whether it's your freezer is open, whether it's your favorite show is about to come on, that text is then entered there in whatever the corresponding language ties to. And so then you'll also see there's some attributes and custom attributes. So this is where things like if you have an additional image that you want to get sent along with the notification, or if there's some audio content, or if you have other custom attributes that you want to throw in, that's where those can get added into the notification. And so you'll notice here, if you've seen some of the other presentations we've done, we talk about notifications having a TTL, or a time to live. And so you'll notice that the TTL is not actually a part of the wire protocol, and that's because the TTL is really used by the notification service itself. And I'll go into that in a little more detail in a few slides here. Okay, so this shows a quick example of two of the notification service sample applications. So one that's the producer basic app here that sends a notification, just a default canned notification, and then the consumer service that acts as a very basic command line consumer. So these are both C++ command line applications. If you download and build the source code, you can run these. And so really this is just to illustrate what this looks like, what a notification looks like from a code perspective. So the producer just sends out this canned notification, and then here on the consumer side, we can go ahead and see here's what the message ID is, the device name and the app name. It's an info message, and then we can see there are two different languages that are supported by this notification and what the actual text is. Here are a couple custom attributes that have been put in. And then here we can see some of the other attributes that are available. You can either have a URL for an icon, or you could also have an AllJoyn object path for an icon. And same thing applies for audio. So these simple applications, sample apps that ship with the source code in the SDK, these can really be used also as a helpful development tool. So if you're trying to write a notification consumer that'll run on your smartphone or a tablet or a TV, you can use sample apps like this to go ahead and produce those notifications and help you through the development and testing process. So even though these are the C++ sample apps, they can be, if you're writing an Android application, they could be used with an Android app. And that's really something important to point out. Just like AllJoyn, where it is really cross-platform, has multiple language bindings, because all of the service frameworks are built on top of AllJoyn, they have the same power and the same capability. So you could send a notification using a C++ client, and you could receive it on an Android client. So now, next two slides, I'm going to go ahead and show just a couple code snippets of what it looks like on the producer side and what it looks like on the consumer side. So here we're looking at some code that's used in C++ to go ahead and send a notification. So you'll see that we have the notification service and a notification sender. And so after we've set up about and announced that we support the notification service, we can go ahead and initialize in the sending mode. So we're going to provide it with our bus attachment here, and then we'll go ahead and get the notification sender. So then the next step is to actually go ahead and create our notification. So when we construct a notification, we can provide the message type, and then this vector of messages here, that is the language to actual contents of the message. That's that pair that we went through earlier. And then again, you can set the different custom attributes that are available for your notification. And then finally, right here, you just go ahead and use the sender that we created to go ahead and send it, and that's where you provide the TTL. And so really, kind of the power of showing this code here is how simple it is to send a notification. And that's really one of the powerful and really cool parts of these service frameworks. Is it's not that many lines of code to leverage and take advantage of these. Obviously, the notification service is maybe a little simpler than the onboarding service framework or the control panel service framework that we're going to go into, but it's really pretty easy to use. So again, this is some Android source code for the consumer side, and so what we're doing here. As I mentioned before, you'll see a lot of this in our examples. We've got the about service. We're starting the about client, so we're going to go ahead and discover other devices out there that can emit notifications. And then we're going to take the notification service and start it up in receiving mode, again giving it our bus attachment. And we're going to register this application as a notification receiver. This line right here, where we're adding a sessionless signal match, that is that's just another part of AllJoyn that that needs to be set up. If you saw any of the previous presentations that Brian did, where we talked through sessionless signals, what they are, how they work, this is just another part of the code to basically let this bus attachment know that we want to listen for sessionless signals. So then this method right here, the receive method, this is what's actually going to get called by the notification service framework when a new notification is received. And so in this method, we're just getting the application name, and then we're calling this render method. And basically what this is doing, this is where you as a developer could put your code in, doing whatever you want to do with the notification. If maybe if you want to render it in some kind of a pretty pop-up to the user, this is also where you could do filtering. So another example, if you have a lot of devices in the home that are sending out notifications, maybe the user wants to be able to filter on what kind of notifications they receive. Maybe at night they only want to see emergency notifications, or maybe they don't want to see notifications from their washing machine or the refrigerator. So again, that's kind of the power that you have as a developer, is to take this service and extend it and use it as you'd like in your application. So finally, this is a diagram that's taken from the Notification Service Framework interface spec. And so this just kind of breaks down the call flow of how a notification flows through the Notification Service Framework and through AllJoyn. So here we have two consumers and one producer. So you can see if we have our producer, it's going to go ahead and send out a notification. So under the hood, that's going to send out a sessionless signal. And so we noticed here that both consumers have registered to listen for and receive notifications. So then each consumer is going to go ahead and receive that sessionless signal broadcast, and then they'll go ahead and pull over that notification. And then at that point, the notification is delivered to the consumer application and can be displayed however that application wants to. Okay, so a couple quick things to cover here about just some best practices in debugging with the notification service. The TTL should really be set to correspond to the type of information that's in the notification, as should the message type. So really, you can imagine as an end user, if you get a notification and the information that's contained in it was only valid for 5 minutes and now it's 2 hours later, that's not really very useful. So that's why, as a developer creating these applications, you want to make sure to set up the TTL to correspond to the type of information that's in the notification. And at the same time, if you're getting something, like the lights have turned on, that's not, in most cases, that's probably not an emergency. So you really want to make sure that the message type corresponds to the data contained in the notification, because different consumer applications may use that message type to go ahead and filter and decide whether they even display it to the user or not. And then finally, as I mentioned before on the debugging front, there were the couple command line apps that I talked about a few slides ago. So those can be used to both send and receive notifications. And the big thing to point out there is that it is cross-platform. So you could use the command line app to send a notification, and you can then receive that notification on an Android app. And so again, that really shows the power of the AllJoyn service frameworks. Okay, so now that we've covered notifications, I'm going to go ahead and move on to onboarding. The onboarding service framework obviously accomplishes a completely different purpose than the notification service framework. And so with onboarding, it's really designed to provide a standard way to get all of these new smart devices that we're going to start having around us onto a Wi-Fi network. So you go out and buy this fancy new Wi-Fi enabled smart AllJoyn connected device, and how do you get it on your home network once you bring it home? So in this case, just like with the notification service where we had a producer and a consumer, the terminology in the onboarding service framework we have an onboarder and an onboardee. So I will be try and be clear when I'm pronouncing those, so I don't run them together. And the onboarder is the application that is going to be used to go ahead and bring the onboardee onto a Wi-Fi network. So the basic flow that happens here is the onboarder is going to go ahead and discover a device nearby that needs to be onboarded. It's going to go ahead and connect up to that device. And then the onboarder it can go ahead and use the information it has, generally supplied by the end user, to configure the onboardee with the information it needs, like the SSID and the password and maybe the security type for the home network, that the onboardee needs to go ahead and connect. And then the onboardee will go ahead and connect to the network, and then at the end, both the onboarder and the onboardee are on the network, and they can communicate whether it's been successful or not. And I'm going to go ahead and go into a lot more detail. That just kind of wanted to get the high-level flow down there of how this works. And so this can really be useful for headless devices or devices maybe that don't have an easy way for typing in an SSID and a password. Maybe it's a really small device. It doesn't have a keyboard. It doesn't have any kind of a touch screen. That's really where the onboarding service can come in handy and be really useful. So again, here's a high-level diagram just showing where the onboarding service fits in on both sides, whether it's the onboardee or the onboarder. So here on the left side, this is showing the device that we're going to onboard. And on the right side here, this is the configuration device. So this is generally this will be an application running on a tablet or a smartphone. And so again, we can just see that there's the AllJoyn core here. That's what's going to go ahead and do all the communication back and forth between the two applications and devices using AllJoyn. And then there's the onboarding service itself that spans across the AllJoyn core and into the application on both sides. Okay, so this again is the onboarding service interface, and so what we can see here is obviously a little more complicated and involved than the notification service framework. There's not just a single sessionless signal. So what we can see here is there are different properties, methods, and signals. So I mean, obviously, AllJoyn, there are those different mechanisms to go ahead and communicate. So what we're going to see here. There's the state that the onboarding service is in. You can also go ahead and, with the property, retrieve the last error that was reported. So maybe if a user doesn't type the password to their network in properly, or if there's an issue like that, that can be obtained via that property. And then we're going to go ahead and see here's the method used to configure the Wi-Fi. And so these are the different arguments that are available. Connect is called. Once the Wi-Fi credentials have been supplied to the device, then the onboarder will go ahead and call the connect command. And then on top of that, there's also, in addition to onboarding, you can offboard, and then get scan info. That can be called from the. Sorry, everyone, 1 second here. That the get scan info, that can be called from the onboarder to go ahead and get what nearby networks the onboardee sees. Okay, so without going into too much detail on that, the next 5 or 6 slides, I'm just going to go ahead and step through what that onboarding process looks like and show what the code looks like on both sides, both on the onboarder and the onboardee. So here on the onboardee side, we're going to go ahead and have that generic AllJoyn boilerplate setup with creating a bus attachment, setting up the different listeners, and then using about to announce that that this device supports the onboarding service framework. So the onboardee is really the first step is to go ahead and go into this soft AP mode. So that code, we're not really showing it here because it's often very device-specific code. So whether you're on some kind of embedded platform, it depends on what operating system you're on, whether you're on an embedded one, whether you're on an Android platform. So that's really something that the onboarding service can leverage. So what we're going to go ahead and see here, this code right here is using the about service to go ahead and register, saying, hey, I support the onboarding service framework, and then go ahead and set up and register with the onboarding service. So that's really the first step. So you have this device that you brought home. It goes into soft AP mode and says on that soft AP, it uses AllJoyn to announce that it supports onboarding. Okay, so step 2 on the other side, on the onboarder side. So this is on your handset or your tablet side. The onboarder application is going to go ahead and scan and look for nearby soft APs. So it's trying to find that soft AP that the onboardee has set up. And so what we really recommend is that the onboardee, when it's establishing that soft AP, that it uses a specific naming convention for that soft AP name. And so that makes it much easier on the onboarder side to go ahead and find those soft APs. And so for some specific guidelines and examples on that, it's best to refer to the Onboarding Service Framework interface specification. So one thing to note, if you've looked at any of the sample code that we have available for onboarding, the sample apps often expect a specific soft AP name and security that's already been hard-coded. So that's just kind of one thing to keep in mind. And again, just as actually establishing a soft AP is often very language and platform specific, so is scanning for nearby networks. That is also language and platform specific. So that's basically why we're not going into that portion of the code here. Okay, so the third step, so once the onboardee has advertised the soft AP and the onboarder has found it and connected up, here's where, here's where all the magic starts to happen. So once they're both on that same soft AP network, the onboarder will go ahead and see that about announcement, and then it can use the info in that about announcement to go ahead and initialize a connection from the onboarder to the onboardee. So the code that we're seeing here, this is the on announcement handler that is on the onboarder side. This is an example from a sample Android application. So when that announcement is received, what we're checking for here, it's getting the device ID, it's getting the device's friendly name, and then this add device method is going to go ahead and say, okay, this is a nearby device, and it's going to check, does this support the onboarding service framework? And so if it does, it's going to go ahead and use this information here, the device ID, the bus name, and the port, to go ahead and connect up to the onboardee device. So when that onboardee starts up, it's going to go ahead and establish an AllJoyn session. And so at this point, the onboarder is going to go ahead and join that session. And that's all being done under the hood by the onboarding service. This isn't something that the developer needs to write. That's actually accomplished by the onboarding service itself. But just to give everyone an idea of kind of what's happening behind the scenes. Okay, so once that session has been joined, now the onboarder is going to go ahead and provide the credentials for the home network. So what we're seeing here, two different pieces of code. This first chunk here, the configure Wi-Fi method, this is what's going to get called on the onboarder side. So it's providing the SSID, the passphrase, and then the authentication type. And so this is really where this can be presented to the user asking them to choose their home network from a list that's been retrieved from a scan. They can be entered manually. This could be, accomplished a variety of different ways. And so really what's happening under the hood is the onboarding service framework is going to go ahead and set up the proxy bus object and then use the onboarding transport to go ahead and call this configure Wi-Fi method. Okay, so the next step that we're going to have here on the, so this is on the onboard E side. This configure Wi-Fi handler, this is going to get called when the onboarding service receives the configure Wi-Fi call over the AllJoyn interface. So again, this is all this source code we're seeing here. This is the source that's part of the onboarding service framework. This isn't code that you as an application developer are going to have to write. This is really just to illustrate how the onboarding service is working under the hood. Okay, so once the Wi-Fi credentials have been provided to the onboardee, it's going to go ahead and try and connect up to that home network. And so that can be, whether that's successful or not, if it is successful, we'll move on to the next step. If not, it can go ahead and fall back to the previous step where we're still in soft AP mode. So maybe the user typed in the SSID or the network password wrong. So again, we're showing code samples here from both sides. Up here, this connect Wi-Fi command, this is what's going to happen. So once the users put the credentials in and hit connect, then that's going to be used by the onboarding service to go ahead and call the connect method on the onboardee side. So what we can see here in the comments and then in the code is this is kind of an empty implementation, and really that's because making the calls to set up what the SSID and password are, talk to the Wi-Fi driver, and then go ahead and maybe stop soft AP mode and connect up to a local access point. Those again are all device and platform and language specific commands. So that's why we're not going through them here. And so the final step, once the onboarder and onboardee are both on the home AP, they can go ahead and the onboardee will go ahead and re-announce saying, "Hey, I'm here. It worked." And then at that point, onboarding is complete. So in the event that something something does go wrong, that does occasionally happen. If we recall back to the interface specification, there's a state property. And so this is really kind of like a state machine for the onboarding service. And so it can point out what state we're in. So the personal AP is either not configured, so we're just starting out. It's been configured, so the SSID and the password have been entered, but we haven't tried connecting yet. Then validating is when we try connecting. Validated means success. And then error, retry, those are all obviously self-explanatory. Okay, so once we've gone through the onboarding, one question people might have is, hey, I want to try and use this, but I don't have some AllJoyn enabled device that I can just play around with and try and onboard. So that's where there's a simulator application that can be used. It's an Android application, and it runs as a background service, and it will basically simulate a device that can be onboarded. So it supports onboarding about and configuration. And so this can be downloaded from the All Seen Aliance website. And so this really can just be used. It uses an Android phone to go ahead and simulate a soft AP and go through all those steps that I just went through. So it's really a handy development and debugging tool. So finally, after we've gone through the whole onboarding process and this new device has been onboarded, this is where the config service that I mentioned earlier, this is where the config service can come in. So the config can really be used to set some different persistent values for an application or for a device. So the example I'm going to go through here is this friendly name. So you get this fancy new AllJoyn enabled device, you bring it home, you set it up, you put it on your network, and then you want to give it a friendly name. So that way when you get notifications from it or when you want to use its control panel, you can actually recognize what it is. And so that's just an example of one of the things you can do with the config service. Again, config can be used for other things too, different device configurable options, stuff involving security, different things. Really, it's up to the end developer. It's kind of one of those open-ended services. Okay, so finally, third service framework that I want to go through is the control panel. So again, control panel is much different from the previous two that we've gone through, but at its core, it's still all built on top of AllJoyn. So we're still going to be looking at interfaces. There's bus methods, there's signals, there's properties. You still have sessions. So again, that's just kind of I just want to point that out because that's showing really how versatile and how powerful the AllJoyn framework can be. So with the control panel, the idea here is really being able to have an infrastructure or a model for a device to expose controls to other devices and applications. So the terminology we have here, the control E is the device that's going to be controlled. So maybe this is your refrigerator, a washer, a dryer, a TV, maybe even another smartphone. And then the controller is the device or the application that's going to go ahead and render those controls and allow the end user to interact with them. And so one of the big, one of the powerful parts of the control panel service framework is that it provides this generic mechanism for an app to control any number of different devices. So just a couple different examples like what I went through before. Maybe you get a notification saying that your oven's ready to start, it's warmed up, ready to start baking. So you could use the control panel to go ahead and interact with your oven. And so this diagram here is I'm just going to kind of talk through the different steps that are used, the different steps that are used as part of the control panel service framework. So what we have here, imagine we've got a refrigerator. So this is the control E, the device that's going to be controlled. And then let's say we have our smartphone or tablet over here. So it's going to use, so via about, we will have detected that, hey, there's this refrigerator. It supports the control panel service. So let's go ahead and fetch what the different controls are. So after those controls have been retrieved, from the app running on the refrigerator here, it'll go ahead, the app running on the smartphone or tablet here will go ahead and render those controls and what the current values are. So here we're just seeing what the temperature settings are for the freezer side and the refrigerator side. And then let's say the user wants to bump the freezer down a little bit or maybe make something warmer or cooler. So at that point, once they've interacted with that control on the mobile application, that will actually use the control panel service to send that new value back over to the refrigerator. And then that can be used by the control code running on the fridge to modify the temperature. And so that's really kind of what the control panel service is allowing is it provides not only the mechanism to go ahead and expose these different controls, but it also allows the mechanism to provide different hints on how you want the controls rendered on the viewing side. And then it also provides the different callbacks and tie-ins that can be used on the platform being controlled. And so the example of that would be once this new freezer temp has been provided back to the refrigerator, there's the platform-specific code that would get called that actually goes in and interacts and changes what that temperature setting is. So here's our diagram that just shows kind of the different pieces of the control panel service framework and where they fit in. If you'll notice here on the controllee side, we've got the different control interfaces and the metadata. And then in addition to that, on the controller side, we see this thing called the UI toolkit adaptation layer. And so really what that is the control panel service kind of has two parts. It has the base part that provides the different controls and interfaces and the communication using the AllJoyn framework. And then the second part is this adaptation layer that can be used on the controller side. And this is really a platform and language specific piece that provides the mechanism to go ahead and render what the different controls look like as a widget. So this obviously would be different on different platforms, and we'll see a screenshot here in a minute of what that looks like. So here are the different steps for creating a control panel. So imagine you have this. Let's take the refrigerator use case that we've been working with. Imagine you have this refrigerator and you want to go ahead and design a control panel, set that up, tie it into the platform code that can change the freezer temperature, change the humidity levels, all that kind of stuff, and then go ahead and advertise that using AllJoyn. So the first step is to go ahead and use XML to design what your control panel is going to look like, what the different controls are, what the different values, how that's going to interact with the platform specific code. And here I say design and not define, because basically you use the XML to design your control panel, but then the second step is to use the code generator tool. And this is a tool that's included with the source code as part of the different SDKs that are available. And so after you've written the XML to go ahead and define your control panel, you'll use the code generator, and that will go ahead and produce the actual source code in whatever your target language is that has the different uses the different AllJoyn interfaces and bus objects to go ahead and create this control panel. So then once you've actually generated that code, if any of you have looked at the control panel service framework before and any of the documentation that goes along with it, there's this generated code, and then there's also the provided code. And so what the provided code is, this is the code that is application, device, or platform specific. This is what actually, this is what maybe interacts with the actual hardware that you're working with. So the example I gave before, this is the code that will actually go ahead and change the temperature on the refrigerator or the freezer. And so when you're using the control panel service framework to go ahead and create these applications, there's callbacks and hooks that are set up where you can tie into that code. And so really, once you've defined your control panel and generated it using the code generator, and then you've set up your provided code, then really what the control panel framework itself does is it actually kind of ties both of those together and provides a cohesive application. And so to see some different examples of what the different XML looks like, and then the control panels that are generated from it, and then also to see how, once that code has been generated, what that looks like at the AllJoyn level. So what the different interfaces look like, how the bus objects fit together. There's some good examples of that in the interface spec for the control panel service. So what I'm going to go through here is actually show a few different snippets of what some sample control panel XML looks like, and then go ahead and show a rendering of what the widgets, the corresponding widgets would look like on the controller side. So here we can see there's some different properties. So when you're setting up your XML, and again this is listed out in the interface spec and in some of the guides that are available on the website, what your different controls are. So there's, if you want to just have a simple label on your control panel, there's a couple definitions for that. If you want to actually have properties that are editable, so maybe you've got a temperature setting, maybe you've got a mode, maybe you're using a control panel on something that has a clock to it, and so you want to use some kind of a clock picker widget to go ahead and set the time. All those different things are available as part of the control panel service framework. So what we can see here, so for example, the control panel we're working with here, this is one of the examples that's available as part of the source code. This is basically just a really simple oven example. So the heat property, this get code and set code that you see right here, these are the functions or the methods. These are what tie in, this is the platform specific code. So when we run this XML through the code generator, it will go ahead and set up callbacks looking for these two different functions. So when the control panel wants to get whatever the current heat is, it'll actually call this get uint 16 var function right here. And then let's say the end user goes, well, say the oven's at 300 degrees Fahrenheit, and the end user wants to set that up to 400. Once that's done, the control panel service framework will actually call this set uint 16 var function right here and pass that value in. So I know this may be a little bit difficult to visualize just from looking at the XML, but if you actually go and look at the examples in the source code, it is a little more clear. And so then these other values we have here, whether this is a secured interface or not, enabled, this can be set to true or false, and this can be done dynamically at runtime. So an example of this, maybe depending on what mode or what setting the device being controlled is in, there may be certain values that are only usable in that situation. So that's what you can use the enabled portion of a property for. And then again, writable, this can be true or false. If it's false, then it acts like a read-only property. So maybe, again, there's a lot of different examples out there that we could use for this. Sticking to our oven example, maybe once the temperature has been set, maybe it can't be editable in a certain mode. So that XML that we just saw, the actual XML that's used to generate this control panel, where we're seeing a picture of here, is a lot longer than what would fit just on that one slide. Basically, we were showing kind of the beginning here, and then one of these temperature widgets, just to give an idea. But the full XML is available in the source code. So what we're seeing here is just a quick screenshot of the control panel browser application. And so this is available as part of the control panel Android SDK. And so this is showing what that control panel would look like. And so these are some of the different, you can see there's a few different button widgets here. We've got kind of a drop-down picker, a few different labels. And so this is a real basic control panel. And it's important to point out that using the XML and the control panel framework itself, you can set what you want the layouts to be, whether you want them horizontal or vertical, how you want some of these different widgets positioned, if you want a property to be represented as a button or a drop-down spinner, or like I said before, some kind of a time or date picker. There's a lot of different options that you have. Okay, so finally here, I just want to go through how the control panel service works, between a controllee and a controller. So on the left side here, we've got the controllee. On the right side, we have the controller. On the controllee side, we'll go ahead and use the service to register our objects. And so this is the actual code flow. So this is once you've designed your control panel using XML, run it through the generator, and tied it to the provided code on the controllee side. And then similarly on the controller side, it's once you've set up your application and tied in that widget library that I was talking about. So what will happen here, the controllee will send out its about announcement saying that it supports the control panel service. That announcement will get received by the controller, and it'll go ahead and check, hey, does this device support the control panel interface? If it does, under the hood, the control panel service sets up its own session. So that session that's hosted by the controllee will go ahead and get joined by the controller. And then the next step here is the controller will go ahead and step through the control panel hierarchy that's been set up by the controllee device, and it'll go ahead and build out what all the different widgets are. So for that oven example that we've been going through, the current temperature, the mode selector, turning on, turning off, all those different features. It'll go ahead and step through and pull over the metadata for each of those, and then also what the current values are. So at that point, the controller side has enough info to go ahead and render those different widgets in the UI. So then once those have been rendered, then we can go ahead and say, hey, we've got this end user. They're going to go ahead and interact with our control panel UI. So when, so for example, let's say going back to our oven, let's say the end user has set the temperature, the target temperature to be 400 degrees. So that value will go ahead and get passed, the control panel service framework will use AllJoyn to pass that value over to the controllee. And then on the controllee side, that new value will come in, the callback will get triggered for the platform-specific code, that provided code that we went through earlier. That will get triggered, and then presumably the oven will switch over to start heating to 400 degrees. And then at the same time, what's going to happen is once that change has been made, the control panel will go ahead and send out a value changed signal. And so what this is basically saying to any controllers out there, here's a new value that you need to update and display for this particular widget. So you can imagine then as the oven is heating up from 300 to 400 degrees, maybe every 10 or every 15 degrees, the controllee will send out a value change signal so you can get some kind of progress feedback to the user. And then similarly, maybe there's a button for choosing the bake or the broil setting on the oven. So again, that's different from a property, that's an action. And so when the user clicks that button, that action exec call will be made. And again, there's a callback that's tied to that on the controllee side. So that's pretty much a quick overview of the control panel service. Really to see how it works, the best thing to do is just to load up 2 of the samples and step through them. And there are a number of different sample XMLs that show using the different widgets and the different properties. So those are, I recommend looking at those. It kind of really helps when you're first getting started. So that's pretty much it for going through the 3 different service frameworks. I'm just going to do a quick recap here, and then we'll go ahead and go into questions. So we went through the notification, onboarding, control panel, and config service frameworks. These are just some standard building blocks that are built on top of AllJoyn. They all use about for doing advertising and discovery, as we saw in the code snippets that we looked through. And again, I just want to point out that each of these services, just like AllJoyn, they are interoperable across platforms and language bindings. So you could have some kind of an embedded device in C using the AllJoyn Thin client that advertises a control panel, and that could be controlled by a controller application running on an Android device. And so then just kind of a quick recap here on what the 3 different service frameworks really accomplish. Notifications, it's kind of like the text message for the Internet of Everything. That's like a quick way I remember it. Onboarding, it provides the standard mechanism to get a device onto a home Wi-Fi network. And then again, control panel that we just went through, that's really about an infrastructure for exposing user interfaces to remote devices. One couple quick points here. All the source code that we went through and showed in these slides, it's covered under the All Seen Aliance, under the ISC open source license. If you go look at any of the source files that I mentioned today and had links to in the presentation, they'll have this license at the top of them. And other than that, I want to thank everybody for taking the time to join and listen. And I think now we can go ahead and open up for questions.
All right, Mitch, so there's one question on our chat window here. So it says, onboarding may be a resource-constrained device whose OS does not support a soft AP. What about this situation? So the question, how does the onboarding service framework work on a device that does not support soft AP? Yeah. So that's a good question. So right now, the onboarding service is really designed at this point to work with devices that do support that soft AP mode. If they don't, there are other other alternate approaches and paths that could be used to really be able to answer that. I'd probably have to know more about the specific device and use case. That might be a good question for the forums. Because I'm sure if someone has that, other people may have that question. There are other out-of-band approaches that could be used if a device doesn't support that soft AP mode. I would just add also that that these services also are kind of like a moving, evolving target.
Correct.
And we do have working groups for the base service frameworks that you talked about. And I think certainly in the future, there's probably going to be a lot of other really good ideas for supporting different types of onboarding that could be added into kind of the base service frameworks.
Yes, that's a very good point. These are all these service frameworks are they are moving and evolving. We've got the first version of them out right now. There is work in progress to make additional versions of them. And another thing, just quickly to mention, so we went through these three service frameworks today. There are others that are probably in the works, and then on top of that, this also kind of brings up the ability for people to make their own service framework. So there's a whole process for that too.
Okay, another question here. I think it's asking about how does an app and the AllJoyn framework interact? Are there threads, and do they communicate via sockets?
Okay. So that good question. That really depends on what platform you're working on. So different. Obviously, if the platform itself supports threads, then the AllJoyn framework it can be multi-threaded. So that does depend on the platform. That's probably a good question. The two previous presentations that kind of cover the core of AllJoyn and how the core of AllJoyn works, there are parts in that help answer it. So under the hood, at the core level, AllJoyn manages the different transports and different connections between devices. That's really all abstracted from the end user. So when a developer wants to use one of these service frameworks or use AllJoyn in their application, that's kind of one of the nice parts about it, is they're not having to manually go and open sockets, do stuff with the networking stack. That's really all abstracted from them and handled by AllJoyn.
Okay. Another question here about security concerns for onboarding. So it says, number one, some devices which are not owned by the user, e.g. the device owned by neighbors, may be onboarded. How do we avoid this?
That's an excellent question. I actually get that one a lot. But yeah, it's a very, very good question. So with that, so there's the onboarding service framework itself, and then in addition to that, what application developers can do. So say you bring a device home, and your friend, or your neighbor that lives next door, they get another device. So how do you make sure you're not onboarding their device and they're not onboarding your device, or how do you prevent from malicious use cases like that? So when the device comes up in soft AP mode, what developers and OEMs and manufacturers can do is use an additional mechanism. So maybe that soft AP itself can have a password on it, and that password could be there could be a QR code on the box that's unique to that specific device, or there could be a password that's in the literature that comes with the device. There's a number of different mechanisms there that can be used, but it's basically to ensure that when that soft AP comes up, it can be secured with a password and with security. And so that way, only the person who physically has that device can actually connect to it and then onboard it. And then once the device has been onboarded to the user's network, then it relies on the user's home network being secure. And there's a number of different layers involved, with ensuring that security.
Okay. And then another question related to security with onboarding. How do we securely transfer the Wi-Fi passphrase? Password, that is the password of the home Wi-Fi network. It may be stolen.
Okay. So that's where users concerned about that. Right. So again, the use case that I just went through. So the soft AP itself can be secured with a username and password. So at that point, there's the added security of only the one person that has that device and has that username or has that password can be connected to the soft AP. But at the same time, that AllJoyn interface is secured, and that information can be encrypted. So in the previous presentation, we touched on security, the different security models that are available in AllJoyn, and so the SSID password can be encrypted and transmitted securely from the onboardee or from the onboarder to the onboardee.
Okay, so I'm not seeing any more questions here on my chat window. I'm not sure if folks are emailing or IMing you directly.
Give me 1 sec. Let me see if I can bring up my chat window real quick.
So I have another one now. So Mitch, on slide 17, why is sessionless signal used for sending signals when the consumer device is already registered? Aren't sessions already established? Is it for broadcasting?
Slide 17.
Yeah. Want me to read that again?
Sure. So this is with the notification service on slide 17?
Sounds like it, yeah.
Okay. So if you could read that one again, please.
Yeah, sure. So why are sessionless signals used for sending signals when the consumer device is already registered? Aren't sessions already established? Is it for broadcasting?
Yes. Okay. So in this case, the registering for notifications. So by registering for notification, what we mean by that in this diagram is setting up at the AllJoyn level, registering to receive those sessionless signals. So so with this producer and the two consumers, there are no sessions that have been established. The announcement and the discovery was purely done via about, which is all sessionless signals. So there is no session that's been established. So at this point, sending out that sessionless signal broadcast for notification 1, that is a sessionless signal because there is not an existing session. I guess whoever asked that question, does that help answer, or am I misunderstanding the question?
Oh, yes, I got it. Thank you.
Okay.
Yeah, and feel free to ask the questions over the telephone bridge as well. Okay, here's another one. If the service version of both sites are different, one is older and the other is newer, how is backwards compatibility work in this case?
Excellent question. So with that, and Wayne, you can help chime in on this one too. I think our goal is to try and maintain backwards compatibility between different service versions. There may be the case when a newer version might introduce a new feature, but the existing features should still be backwards compatible with previous versions. I think that's our current goal. I'm not 100% sure.
Yeah, and just to add, so each of the services do have versioning. That's kind of announced in About, I believe. And Mitch, you can correct me if I'm wrong.
Yes.
And there's both the major and minor numbers. So if the minor number revs, then everything is backwards compatible. But if the major revs, then it's not compatible.
Correct.
Yeah. So in the code we can detect this and do the right thing. And as Mitch pointed out, yeah, certainly it is our intention to maintain backwards compatibility. So any more questions from anyone? So we did cover a lot of different services. Again, the notifications, onboarding, control panel, config, and a little bit of About as well.
I think I got one more question in the chat window, asking if AllJoyn devices support the About service. So I think if I'm reading this correctly, so the core AllJoyn framework itself, so the About is another advertising and discovery mechanism that is a part of AllJoyn, and so each AllJoyn service, so the different service frameworks that we went through with notification, control panel, and onboarding, those all use About to go ahead and accomplish that advertising and discovery. So a device that has a control panel that supports displaying a control panel, it can use About to let other devices know that, hey, I support the control panel service and I have a control panel that can be viewed. And then on the other side, the client side of About can be used to go ahead and find devices like that that support these different services. So being able to find that device that has a control panel. Did that help answer that question? Okay. All right. Well, I think that's it then.
Okay, great. Thanks, Mitch. And just a reminder, so next week is going to be on Thursday again, and well, I guess Thursday for in the United States. And we're going to be covering. It's more of a kind of hands-on. We're going to show you how to download the SDKs and the code, and then show you how to kind of install it and build it, and we'll run through some of the sample apps as well, covering both Android and Linux. So that one should be pretty interesting. So any more questions before we sign off here? Okay, well, I think that's it. Thanks, Mitch.
Okay, thanks everyone.
Yep.
Bye.